Dear students and participants of the course on railway engineering, today we are going to talk about the permissible values in the wear, and then after that we will start another topic which is related with the long welded rails or the continuously welded rails. If you remember, in the previous lecture we talked about the various types of wear which can appear on the rails. It was discussed with respect to the location on the track and with respect to the position on the rail. After that classification, we talked about the various precautions which needs to be taken and what are the various ways in which the measurement can be done of those wear. In today's lecture, we will going forward with the wear in terms of the precautions against the wear on rails and the permissible limits of the wear, and then after that we will start discussing about LWR or CWR, that is long welded rail or a continuously welded rail, and today we will try to complete the discussion in this particular aspect related to locations, the structure and the provision of LWR or CWR on bridges. So, let us start with the precautions which can be taken on the rails related to the wear. Very first one is the maintenance. We did talk towards the end that the maintenance is a problem, and if we have gone for a better maintenance of the track, then obviously many of the things will remove. The stresses which are going to be induced in the track or in the rail sections because of the bad maintenance of sleepers, bad maintenance of the fastenings and fittings or the ballast or the formation level, then that is inducing those wear. Another thing is reduce the number of joints. Now, when you reduce the number of joints, it means the rail and wear that will reduce, because now these rail ends are not available which are going to be hit by the wheel. So, that sort of a possibility you have reduced. Use of heavier and higher UTS rail sections. We have talked that we can have a 70 to 90 or 110 UTS sections. So, if we use the higher value of the UTS sections in those particular locations where there is a possibility of the rail wear, then probably we are on a safer side. Use of the bearing plates. Now, one aspect we talked about that there is a tilt which is being given to the rail. So, the rail is being tilted in this form. So, there is 1 in 20 slope, and that has been done because there is a coning on the wheels. But at the same time, if the sleeper has been edged in this form, so this is the sleeper. So, that edging of the sleeper is being done. This edging of the sleeper induces the wear move, and that has been observed. So, instead of that, it is better if we use the bearing plates here. When we use the bearing plates and there is a requirement of giving this particular slope, then there are canted bearing plates available. So, this is a canted bearing plate, and at the top of this canted bearing plate we can put, because in the case of this edging, what may happen is, another thing which may happen is the deterioration which is occurring in the sleepers. This rail seat may get inside the sleeper, and as soon as that happens, then the loosening will be there. Lubricating the gauge face, we have talked towards the end that what are the ways in which the gauge face can be lubricated, but we are not talking about the lubrication of the side of the rail head. Use of check rails on the sharp curves. These check rails helps in terms of the lateral movement of the rail which may occur on the curve. So, there is another rail being provided inside at this location like this. So, there is a check rail which will be helping in this particular lateral movement. Track renewal. If the track is having a problem, that go for the track renewal, that is another way of improving upon the system and reducing the wear. Interchanging inner and outer rails. Yes, it is possible. We did talk about it in our previous lecture. We said if more of the wear has happened on the inner side or the gauge face, then let us rotate it by 180 degrees, and that gauge face becomes non-gauge face and non-gauge face becomes gauge face, and that is how you can continue with the same rail. Use special alloy steel, and at those particular locations where the wears are possible or they are more in terms of their intensity, special alloys can be used in the steel. Regular maintenance of the rail joints, that means you are looking at the gap, you are looking at the fastenings. Both of the things have been looked here. So, if they are perfect, if they have been tightened, then the wear will not be there. The welding or the dehogging of the battered rails. So, those ends either you are dehogging, we have discussed about the dehogging previously when we talked about the hogged rails, and if some of the portion has to be cropped, then we use another rail section and being placed there and we weld it there. Maintenance of the correct gauge, and when the gauge is correct, then the lateral movements or the pressures which are going to be induced, that will reduce. So, it will have an impact with respect to the lateral force. Then application of the heavy mineral oil in case of the corrosion of the rail metal under adverse atmospheric conditions. This is another thing which can be done. So, any such location where the corrosion is a possibility and the rail has started corroding, then we can use this heavy mineral oil so that the rust can be removed and it can bring back to the most possible normal condition. Then some specific precautions here which we are talking is with respect to the outer rails on the curves. What we are talking here is to lubricate the gauge face of the outer rails on the curves. So, there are different type of such lubricating devices available. So, there is a track mounter automatic track gauge face lubricator. You can see here in the photograph being shown on the right hand side. So, this type of a lubricator is there. You can say this is TMATGFL. So, that can be used, and if the rail grinding is in practice on a route, then use this on curves of radii 1400 meters and sharper than that. That means we are talking about 1400 meters, the degree of curve is around 1.25. So, in those particular cases, and the grinding is also being done so as to remove the corrugations. We discussed about the corrugations on the rail head, and then we said there is a grinding machine, there is a trolley, there is a hand equipment which can be used to grind the surface and make it to the smooth leveled condition. Then lubrication should be done if the rails do not have gauge corner cracking or the head checks. This gauge corner cracking or the head checks again in the previous lecture we have talked about. Then the gauge face of the outer rails on the curves, lubrication should be located on the tangent track at the beginning of the transition curve where the wheel flange is just beginning to occur. So, this wheel flanging means it is going to make an impact with respect to the side of the rail head. So, that is going to start because if this is a main curve and then a transition curve has been provided here, and after that there is a straight section. So, we have a transition curve, this is a circular curve and this is a straight section. So, the wheel flanging will start occurring as soon as we are starting moving on this transition curve. On single track, the lubricators shall be located in the direction of heaviest traffic. So, what should be the location of those automatic lubricator? That is what is being talked here. So, looking at in which particular direction the traffic is more, that should be used. The lubricators shall be located away from the switches, from the crossings and the locations where there is a discontinuity in the LWR track. If any of such things are available, if you are reaching a switch or a crossing, that means here we are talking about point and crossings, or we are talking about turnouts. So, at those particular locations, this lubricator should not be provided, we have to be beyond that location. Or if there is a discontinuity in the LWR track, means the LWR track which is a continuous welded track, say the welding has been done on all of these locations on this rail, so that the rail panels has been converted into a continuous rail section, and these joints they are welded joints, but at one particular location here it may happen that there is another track which is starting as an LWR. So, here this discontinuity will be there and this will be joined by the fish plates and the bolts. Then maintain the correct curve geometry as well as the super elevation. This is the design side as well as the construction side. So, you need to have a good design and a good construction practice here. So, these two aspects are being looked here. Provide suitable check rails wherever there is a requirement in terms of the movements. Adopt the slack gauge PSC sleeper as per RDSO drawings depending on the curvature of the track. So, they are already being identified, they are already being reported in their literature. You have to look at that RDSO drawings and work according to it. The wear on switches can be reduced by lubrication of the gauge face of the tongue rail. As I said, this tongue rail we are going to discuss when we will take up the points and crossings, but just a simple idea which I can give it to you is, say if there is a movement in this form, now the train can go straight or the train can take a turn and can go to this point. So, therefore, at this particular location there is, if you talk here, there is one rail which is an outer straight rail and there is another rail which is provided in this form, and this rail can move this side or this side. So, in this case when it is straight and there is a certain clearance as being shown here, the train will go straight, but if it touches the outer rail then the train will shift to the side track. So, that is a tongue rail we are talking here. So, this is a tongue rail. Now, what are the permissible limits? The permissible limits, the limiting loss of section in the case of 52 kg per meter rail section for a broad gauge it is 6%, and in the case of 90R rail section on the broad gauge it is 5%. So, this is the limit with respect to the section. The wear due to corrosion more than 1.5 mm in the web and foot indicates that you have to go for the renewal of the rails. So, this is the value, and this corrosion is going to be more on the web and the foot because of the obvious reason, and those reasons we have discussed when we talked about corrosion. Then vertical wear which appear in the top surface. So, in the case of 60 kg per meter rail section you can have a 13 mm of the permissible value, but for 52 kg per meter it reduces to 8, and if you go further down to 90R rail section that it reduces to 6 mm. And if you remember what we said, that with the wear which is going to be measured, it is being measured at 13 to 15 mm below the top surface. Okay, so, this is the area where the curvature is there and there is a possibility, and finally you come to this particular location by removal of that much amount of material which is permissible here. Now, lateral wear which is measured in 13 to 15 mm below the rail top table, that is rail top table is this rail top table. So, in the case of broad gauge we have two types of sections, can be curved section or a straight section, and within the curved section and the straight section again based on the classification of the track, if you remember in the very starting we did talk about it. So, there is a group A and the B track or a C and a D track. Say for a curved section for a group A and B track the value is 8 mm, this is permissible as far as the lateral wear is concerned. So, we are talking about the lateral wear here. So, this is lateral wear. Whereas, in the case of C and D it can be increased to 10 mm. So, if we talk about the straight section then these values reduces by 2 mm and they become 6 mm and 8 mm respectively for the curve for the broad gauge section for the group A and B track and the C and D track respectively. Then permissible vertical wear at the maximum on the wing rails or on the nose of the crossing. So, if you go back, so there is a nose of the crossing. So, this is a crossing. So, this is a nose, and here there will be a rail which will separately be provided. So, wing rails will be there. Of course, all of these track geometries we will be discussing when we will go for the turnouts and crossings. So, in that particular case, this is maximum 10 mm. Then in the case of Rajdhani or Shatabdi routes, the reconditioning or resurfacing of the crossing and the wing rails, they should be planned by welding on reaching the following wear limits. In the case of built up or welded crossings, it is 6 mm. In the case of CMS crossing is the cast manganese steel crossing, it can be 8 mm. And in this case of a CMS crossing, to account for 1 in 20 cant which is given to the wing rails, a deduction shall be made from the wear measurement to record the actual wear of the wing rail on the nose. It means what you first do is you will calculate what is the total wear which you have found out by doing some measurement. And once it is being done, then the deduction is to be subtracted from that, and that will give you the actual wear which has happened. So, what is this deduction at these locations where we are talking about the wear of the wing rails or the nose of the crossing? So, those deductions are given here. It says in the case of 52 kg rail sections it is 2 mm deduction, in the case of 60 kg rail sections it is 2.5 mm. And if it is a heat treated welded crossing, then it is 3.5 mm. So, these are the deductions which are given. So, you measure first of all the total wear, then deduct this, and that will give you the actual wear condition. Now, let us shift our focus from the wear, from the fractures, from the defects on the rails to the long welded rail. Now, this long welded rail is one thing which has been taken up even on the Indian railways in a much faster manner, so that we can reduce the number of joints which are being placed using the fish plates and the bolts, which otherwise becomes the points of weaknesses, which otherwise becomes the points where the sabotage can be done. Those bolts can be loosened or can be taken out, or the fish plates can be removed, and in that case the two rails which otherwise have been jointed, now they will not remain jointed, and there will be a movement of the rails in the lateral direction may cause derailment. So, what is this long welded rail? A welded rail wherein the central part of which does not undergo any longitudinal movement due to the temperature variations. That means there is a big rail being provided in this form, there is a track being provided in this form, there is a temperature change which is happening with respect to the implementation temperature or the temperature which is a de-stressing temperature, or that TD is the de-stressing temperature, or this is a zero stress temperature TO. So, with respect to these, if there is a change in the temperature, this rail starts moving. There will be a expansion or contraction. So, when this expansion and contraction is there, whether this whole of the rail section is going to contract or expand, it is not a case. Based on this delta T, based on the material characteristics like E, that modulus of elasticity, or alpha, which is the coefficient for this expansion and contraction. So, based on these things, and as well as the amount of length which is going to be affected. So, say this is a length L1 here and a length L1 here, only in a certain length this movement will be there with respect to the change in temperature. So, this central portion is not getting affected. If this is a type of system which is provided, then this is a long welded rail. So, therefore, what we need to look at in these type of cases, what is that particular length which is going to move, which is going to expand or contract. The length of the welded rail greater than 250 meters on the broad gauge will normally function as a LWR. Now, the minimum length of this LWR, this is going to be dependent on what? This is going to be dependent on the range of the temperature variation, as I said, delta T. So, it is going to depend on this, because you are talking about alpha, which is coefficient of this expansion contraction per degree centigrade. So, delta T is required. The section of the rail, whether you are talking about a heavier section, you are talking about some light section. So, heavier sections, that movement is going to be lesser. Resistance which is offered by the rail sleeper fastenings. Now, when this particular section is moving, in this case there are sleepers being provided. Based on the sleeper density, these sleepers will be there, and these sleepers, they have been jointed here with the rails. So, there are fastenings being provided here. Now, if these fastenings are being provided, they have been jointed, then if the movement is there, then these fastenings will try to resist, and that will also define in up to how much distance it is going to happen. Now, when this resistance is being talked, or if you are talking about the resistance per sleeper, and if you multiply this with the number of sleepers which are being provided here in this length. So, whatever this total resistance will come, this is R T, this has to be looked with respect to the force, the thermal force which will get induced due to delta T, and that is what is the concept of this movement, and that is what is the concept of this design. Now, resistance offered by the ballast to the sleepers is an additive thing which will be there. So, these two things together will provide the total R, and that will resist the movement, and that will define what is going to be the value of L. In the case of the continuous welded rails, which also define at CWR, it is a LWR, but the de-stressing of which is done in stages and is usually longer than 1000 meters. It means more than 1000 meters, if the rail is being provided without any fish plated joints, then that is a continuously welded rail. And this allows the removal of the points of weaknesses, all those joints which are fish plated joint. They are the points of weaknesses. So, they needs to be removed. These are basically at the switches or and any of the such joint. The guiding principle I already talked about. The guiding principle is the theory of locking of longitudinal thermal stresses. So, whatever thermal stresses have been induced here, we try to resist them by way of the packings, by way of the fastenings, and that is how we come to know that what is be the value and what should be the this continuously welded rail length. What are the advantages of LWR and CWR? Let us look at that. It eliminates the fish plated joints. So, obviously, it improves the safety because the points of weaknesses are removed, the points where the sabotage can be done can be removed. Reduction in the large dynamic forces. These large dynamic forces, they are associated with the speed, and when you have provided the fish plated joints, then they hit, the wheel is going to hit the rail ends and causes the cracks, it causes the wear, it causes the fractures. So, that is going to reduce because you have already reduced the fish plated joints. The track maintenance, it reduces by 25% to 33%. This is a very heavy value. The cost of maintenance is reducing a lot, and it is happens due to the disturbance in track geometry at fish plated joints, and obviously the fish plated joints have been removed, they have been reduced in number, and that is why this saving is coming up. The wear and tear of the rolling stock, again in this area also there is an improvement, either it gets eliminated or it gets reduced. So, there is a 5% in the case of fish plated joints and the 7% in case of the fuel consumption, we have a positive side. The passenger comfort, it improves due to the lower noise and vibrations, and these noise and vibrations are mostly getting induced at the fish plated joints. So, when you have reduced those numbers, this is also going to reduce and improves the comfort. Now, what are the permitted locations where the LWR or the CWR can be provided? In the case of all new tracks, In the case of the doubling of tracks, you have one track only, now you are making it a double track. So, one you get double track, it means again a new track is going to be there, or you are converting a gauge from a say a narrow gauge or a meter gauge to the broad gauge. In all of those cases, now the preferred condition is go for LWR or CWR. If there is a permanent diversion, we are not talking about temporary diversion, because there is some maintenance works which is going on a specific portion of a track, and we have a loop line available which takes the traffic from one side to the other side of that particular area of maintenance or construction. So, there we are not talking, we are talking about a permanent condition. Completed track renewal CTR or TSR, which is a through sleeper renewal, or the TRR, which is a through rail renewal. So, these points which are there in those particular cases also we should go for LWR CWR. Existing tracks, if they meet the requirements of welding by AT or FB welding process, aluminothermate or the flush butt welding process, if these are the processes we are going in the case of existing tracks, then also we should use LWR CWR. In the yard lines, if condition of all components of the track they are sound and they are not having any deficiency, then in that case we can adopt LWR or CWR. But there are certain locations where these are not fit. What are those locations? If the rails are subjected to heavy crossing requirements, so in those particular case there will be renewals, and if there are again and again the renewals are going to be there at location, then it is very difficult to work with LWR CWR because of the long length. You cannot take out such a big length of the rail and then rework with it. If the formation is weak and track deformations are large enough to lead to buckling, because if it is a big track like this and if the buckling happens in this track in this form, then again it will be difficult to manage it. So, it is better that if you have the fish plated joints and if there is a buckling in any of the such rail, which is a rail panel of say 13 meter long, and if even you are going for a SWR say 39 meter long rail panel is there, then in that case this rail panel can be removed and the maintenance can be done easily. Formation soil which is susceptible to pumping failure. So, pumping failure means whatever material is being provided at the bottom and some fines or the other materials, they are just going down. So, you have the ballast cushion. At the top of the ballast cushion, then you will be placing the sleepers. Say if the sleeper is being placed here and length, and this ballast cushion is lying at the soil subgrade or the formation. So, there is a possibility that the material, some piping may happen and this material is getting flushed here, and because of that the strength will not be there in this section and will create a problem. So, in those such locations we should not go for LWR CWR. If the track is susceptible to frequent flooding, subsidence and breaching, then in those cases also we should not try LWR CWR. Then on sharper curves with the radius less than 440 meters, again the reason is in these particular cases the stresses, the lateral longitudinal stresses are going to be induced in a much higher manner, and this may require more maintenance in that particular section, and if you are going with LWR CWR it may not be possible to do that. On gradients steeper than 1 in 100, again the same reasons, certain particular rails they may be burning, there may be shelling, there may be flacking, all of those reasons can be there requiring immediate change, and if you have an LWR CWR that immediate change will be difficult. Now, LWR and CWR they may be continued on reverse curves not sharper than 875 meter radius. What is reverse curve? Reverse curve is something like this. So, in this case the curvature is with respect to O1, whereas here the curvature is with respect to O2. So, this is radius 1, this is radius 2. So, curvature is going, and if we talk about this tangent line, which tangent line is nothing but a straight line. So, if we are talking about this, it means one curvature is on one side, another curvature is on another side of this tangent line. So, this is a reverse curve. So, in this reverse curve, it is may be continued if the reverse curve is not sharper than 875 meter radius, whereas on curves with sharper than 1500 meter radius, shoulder ballast of 600 mm over a length of 100 meter on both sides of the common point of a reverse curve shall be provided. So, we are talking about the shoulder ballast, that means whatever the section is being provided, and say here if we look in the form of this way, not this one you take here. So, the ballast is being packed everywhere and is being boxed. So, whatever this distance up to which the ballast cushion is available, this is what we are talking. So, we are saying the ballast, shoulder ballast of 600 mm over a length of 100 meter on both sides of the common point on the tangent. So, common point on the tangent will come here and the distances are being taken with respect to the center point. So, it says in case there is a straight track between the reverse curve, then this 100 meter will be considered from the center of the track. So, if this straight portion is there, then this 100 meter is being considered from this. It means at least 50 meter on this side and 50 meter on this side will be there. But if this reverse curve is in this form, so this is a common point. So, radius is going up to this way as 1 and then on this side is 2. So, with respect to this you are taking 100 meters, that is what was shown here. No such measure is required if the length of the straight track between the reverse curve is more than 50 meters. We already talked about this, that if this length is more than 50 meters, there is no requirement of going for this type of measure. In temperature zone 1, LWR may be, this is laid on the curves up to 350 meters or 5-degree curve. So, again there is a temperature zone 1, 2, 3, 4, there are 4 zones. So, there are different temperature ranges being defined for that. Accordingly, this is being set. Now, following precautions are needed if we are in a temperature zone 1 on the curves. The minimum track structure should be 52 kg meter rail on PSC sleeper, that is a concrete sleeper we are talking, and with a sleeper density of 1540, that is per kilometer is the value, with 300 mm of the clean ballast cushion. And the shoulder ballast for curves sharper than 440 meters of the radius, it should be increased to 600 mm on outside of the curve and should be provided for 100 meter beyond the tangent point. So, wherever the tangent point has been there. So, if this is a tangent point condition and you are starting a curve. So, beyond the tangent point for a distance of 100 meters, we are going to increase the outside ballast cushion. Then reference marks should be provided at every 50 meter interval to record the creep, because there is a possibility of creep because of the induced longitudinal stresses. Each curve of length greater than 250 meter should preferably be provided with SEJ. So, this is a switch expansion joint on either side, and these SEJs, they should be located in a straight track at 100 meter away from the tangent point. So, that is also an issue. So, this is a tangent point with respect to that. So, you are going in this direction 100 meters with a 600 mm ballast, that is one thing we are talking, and we are clearing on the other side for 100 meter. It says SEG should be located in a straight track at 100 meter away. So, that means if this SEG is here, this is how usually the SEGs are shown, switch expansion joint. So, this switch expansion joint is 100 meter or more than 100 meter. Now, let us talk about the track structure. So, this track structure, stable formation with stipulated formation width, ballast cushion below the bottom of the sleepers with approved PSC sleepers and associated fastening. So, this is a common thing which we have already talked about. Minimum rail section is 52 kg per meter, we discussed about it. Two different rail sections are usually not permitted, so as to be welded for making a CWR and SWR, and if different rail sections are used on either side of the SEJ, then combination SEJ, which is of 52 kg 60 kg rail section combination, that can be used. The new rails they shall be without the fish bolt holes. So, any rail which you are now using for going for a LWR or CWR, that means you are going to start another rail here. So, there is no bolts are required, these holes need not to be there. While construction, the rail ends shall be temporarily joined using 1 meter long fish plates. So, we talked about the fish plates before, but in detail we are going to discuss about it when we will take up the fastenings. So, there are different sizes of fish plates, around 600 mm to 1 meters. So, here we are talking that if this temporary jointing is being done, then 1 meter long fish plates is used, and whenever this 1 meter long fish plate is used, they are used with special screw clamps. This is one thing. Another way of doing it is we can go for a joggled fish plate. This joggled fish plate, again, though we will discuss, it is made of the reused fish plates which are having in a good condition, can be reused, and the thickness is increased at that particular location. So, having slotted grooves and bolted clamps with the speed restrictions, the train cannot move with a speed of 100, 80, 60, 70. There are certain speed restrictions which needs to be followed, and usually they are in a range of up to 30 kilometers per hour. The bolt holes, if any, shall be chamfered. If LWR CWR is followed by fish plated track or SWR, then the same track structure of LWR be continued for at least 3 rail lengths beyond SEG. That means, here this is LWR, but now you are going to connect it with SWR. So, the joint will come here. So, this joint when it is coming, so it say it is a fish plated joint. So, with respect to that, it says that at least for a 3 rail lengths beyond SEJ, 3 rail lengths means 13 meters into 3, 39 meters at least. We should go, and this SEJ should be located at that particular location, it should not be very near to it. Level crossings, they shall not fall within the breathing lengths. The breathing lengths I discussed previously, where we were talking about the thermal effect, and I said that if this is a long LWR, only some portion L1 on this side and L1 on the other side of this LWR, this is going to move because of the delta T. So, this level crossing should not be here. If it has to be provided, it means the road is crossing here. So, level crossing will come at this point somewhere. In case LWR is terminated near points and crossings, one 3 rail panel 39 meter shall be provided between the stock rail joint and SEJ, as well as between the crossing and SEJ. So, this is again a condition with respect to the construction of the track at that location. So, very near, if we are coming to points and crossings and our LWR is terminating there. So, minimum 39 meters, which is 3 rail lengths which we are considering here, they should be a distance being provided there. Now, the two conditions, one is SRJ SEJ and another one is between crossing and SEJ. Provide elastic fastenings with adequate toe load, so that the creep can be reduced or can be eliminated. Insulation for track circuiting is done by glued joint of G3L type. If you remember, we discussed about this when we were talking about the welding and when we were talking about the insulated joints. So, when we did talk about the insulated joints, there were two types of joint. One was the glued insulated joint, and there we have discussed this. Then locations of SEJ shall be fixed considering the location of level crossing, bridges, points and crossings, gradients, curves and insulated joints. So, this is related with how the SEJ has to be located on LWR and CDR. If any of these cases are there, it should not be nearer to these locations. Conventional SEJ with a straight tongue and a stock rail shall not be located on curves which are sharper than 0.5 degrees or 3500 meter radius. Improved SEJ, it may be located on curves up to 2 degrees, above 2 degrees and up to 4 degrees approval is required from the higher authorities. So, up to 2 degrees, as an engineer on a track, you can take a decision. And SEJ shall not be on the transition of curves. So, there are number of locations where SEJs cannot be provided. If they have been provided up to certain values, you can do it. Beyond that, approvals are required. So, we close here. So, what we have discussed? We have discussed about the various precautions against wear, the permissible limits of wear, LWR and CWR, their locations, where they can be provided, they cannot be provided, and then towards the end we were discussing about the track structure. We will be talking about the provisions on the bridges regarding LWR and CWR in the next lecture. Till then, thank you and bye.